All right, so we're going to finish up the word problems from week 3. You should have already completed all of the word problems. I'm going to go through I'm going to go over number 6 and number 8, the ones that I told you I wanted you to do on your own, just to make sure that you have both of them done correctly. At any time, if you have questions about them, please make sure that you stop and ask. Any questions, comments, or concerns before we go over number 6 and number 8? All right. Let's see. This is kind of blurry. Okay, that's better. Let me pause. All right. Here we go. This one says you want to go to your uncle's house. You have 2 options. Option A, you take a taxi, which will cost $10 plus $1.50 for each mile or each additional mile. Okay. Option B is to drive yourself. The cost of gas, because you know you got to pay for gas anyway. The cost of gasoline is $2 per mile, period. That's it. After how many miles will the total cost be the same for both options? So we're going to write an equation for both options. We have option, please make sure that you write this down if you don't have it. We have option A, we have option B. Okay? For option A, I already know I'm going to write an equation in slope-intercept form, y equals mx plus b, because they give me a rate and they give me a starting amount. If they didn't give me a rate or a starting amount, then I would be writing the equations in standard form. But because I'm given a rate and a starting amount, I know that I'm going to write equations in slope-intercept form. Okay? So when you write an equation in slope-intercept form, you look for the rate and the starting amount. So when I read option A, it tells me option A is to take a taxi, which will cost you $10. So you automatically have to pay the $10. That's the starting amount. Plus $1.50 for every mile. This is my rate. So M is $1.50 because that's the rate. That's how much it increases for every single mile. That's a rate. So my equation in y equals mx plus b form, or slope-intercept form, is y is equal to 150, which is m, x, plus my b, which is 10. So this is the first equation for the system. Okay? All right. The second equation for the system. It says option B is to drive yourself. So there's no starting amount because you don't have to pay yourself. But what you do have to pay is $2 per mile for gas. Okay? So M is equal to $2. There's no starting amount. So my equation is going to be y is equal to 2x. I know that I'm talking about linear equations because the rate for the first option is the same. It didn't change. It didn't say, okay, for the first mile, it's going to be $1.50, but then for the next 3 miles, it's going to be $2, and for the next, 5 miles, it's going to be $3. The rate of change is consistent for that option. The rate of change is consistent for the second option. That's how I know that we're talking about linear equations, because the rates are consistent for both options. The first option is this. The second option, it is this. Okay? All right, so now I have a system, and I'm going to type this. I'm going to graph this system to see where they cross. Okay? I'm going to figure out, when is it going to be the same amount of money? How do I know what X and Y mean? Great question. I can look at my slope easily and see what X and Y is. My slope is $2, and I'm going to write this in. $2 per mile, 1 mile. So at the top, this is cost or price or dollars, however you want to say it. I'll say cost. You can say price, you can say dollars, whatever. On the bottom is miles. Remember, the slope formula is y2 minus y1. The y's are on top and the x's are on the bottom. So my meaning for x is number of miles. Number of miles. And my meaning for y is cost or total cost. And it's total, look, because y is equal to all of this. So y represents the total cost. Or some people might have said total price or total dollars. It all means the same thing. So in order to figure out where they cross, we're going to use the graphic calculator, okay? So with the graphic calculator, I'm going to type both of these equations in, okay? So I'm going to clear my calculator, 2nd plus 712. To type these equations in, I go to y equals. I'm going to type in $1.50. X is right beside the green. Well, the alpha button is different on, is it green? It's green on that one too. Okay, so the green alpha button is where, beside it is where the X is, plus 10. That's the first equation. Press enter, or you can press the down arrow to go to the next line to type in your second equation, which is 2x. Again, X is beside the green alpha button. Okay? All right, so now what I'm going to do to graph it, I'm going to allow the calculator to figure out a good coordinate plane for these lines. So I'm going to press zoom. Zoom is at the top of the calculator. I'm going to go down to zoom fit and press enter on zoom fit. This is the calculator deciding what coordinate plane to use. For the most part, they usually choose a good coordinate plane for you, especially if you find it difficult to figure out what X and Y values to use. So we're going to press enter on zoom fit. Okay, and we got to figure out where does it cross. Now look, this is not enough space. It crosses somewhere up here. So I need more. I need for my graph to go over some more and up some more. Over on the X and up on the Y. So go to window. Over on the X is changing the X max. It's at 10 right now. I'm going to go to 50. Oh, up on the Y is Y max. That's going up. I'm going to change that to 50 also. Now I'm going to press graph. After I adjust my window or my coordinate plane, I'm going to press graph. And it crosses up here somewhere. So now what I do is, in order to figure out what that point is, I press the second trace button. Second trace, second trace, second trace. That's how I get these options. Then I'm going to choose intersect because I want to figure out where does it cross. Where does it cross? After I press intersect, I'm just going to press enter 3 times. Okay, 1, 2, 3. 1, 2, 3. I press enter 3 times, and my answer is at the bottom of the screen. My X value or coordinate is 20. My Y value or coordinate is 40. So it's 20, comma, 40. 20, comma, 40. Okay? Please make sure you have this. Please make sure that you are able to use the calculator. It is going to be your friend because these numbers are going to be bogus and it's going to be extremely difficult for you to graph them on a coordinate plane. So you want to make sure that you understand how to graph a system in the calculator or equations in the calculator. Any questions about that? Okay. All right. Go ahead, baby. So to clear your calculator, you're going to press second plus 712. Second button, the plus button, number 7, 1, and 2. Okay? Second plus 7, 1, 2. All right, so let's go to number. All right. So let's do number 8. Okay. Did anybody get number 6 right on their own? Okay. Look at number 8. Number 8 says a class of 195 students went on a field trip. They took 7 vehicles. Some of them are cars and some buses. Look at the question. It says find the number of cars and the number of buses they took if each car holds 5 students and each bus holds 45 students. Okay, I'm going to tell you, it is very good to understand how systems when you are planning stuff, because sometimes, teachers, they might have a hard time trying to figure out, well, how many ones am I going to have in order to figure out these students, da, da, da. And I've, I don't know how many times I've had to help some of our social studies those are the ones that like the field trips. We don't really like field trips. Math teachers don't. Help them with trying to figure out the money part of the field trips because they all the way do not know how to do this stuff. I mean, it really helps in real life situations to really understand linear functions. Not so much some of the other functions, but linear functions, especially because you use that more. And sometimes people have no clue as to how you figure that out. And you're like, yeah, like I don't want to take the time to tell you. Let me just do it for you real quick. You know what I mean? So, I mean, this really does, it's something that really you will do in the future if you know how to do. Or you might just ask somebody like me that knows how to do that to do it for you, okay? All right, but you should want to do this on your own. All right, it says, again, a class of this many students went on the trip. And they took 7 vehicles. Some of them are buses and some of them are cars. Okay. All right. They want you to find the number of cars and find the number of buses that we use. A car holds 5 students and a bus holds 45 students. And you won't believe how long it takes people to figure this out logically. Okay. All right. So think about it. Think about it though. Here, the two unknowns are going to be the number of cars. I don't know that. That's my unknown. And the number of buses. Now, already, they didn't give me a rate of change. They didn't give me a starting amount. So I know I'm going to be writing the equation in standard form. Okay. Where C is going to be my or totals. Okay. So that's how I know right there. Look, they didn't give me a rate of change. They didn't give me a starting amount. So I'm going to have to write this in standard form. Period. Okay. All right, so now in order to do that, I need my totals. So look, they give you 2 totals. They tell you there are 195 students, and it's important to know the units. We're adding up students here. This is important. And then they give you another total. They tell you there are 7 vehicles. Okay? Any questions about how I got any of this information so far? Now we got to use the information that's given to write the equation. The easier one, of course, is the 7 vehicles. Okay. Some of them are cars and some of them are buses. I don't know how many are cars. I don't know how many are buses. So I'm going to say the number of cars, that's X, plus the number of buses, that's Y, is equal to a total of 7 vehicles. Any questions about how I got that equation? That was the easier one. Now I'm adding students, okay? I'm doing students. Any guesses as to how I'm going to write the equation to figure out that there are 195 students? Any guesses? Very good. 5x, and it's 5 because, look, a car holds 5 students. So that means for every car, you're going to multiply 5 times how many cars there are. So we got 5 times X. So if I had 2 cars, how many kids is that? How many students is 2 cars? 10. Okay? All right. Plus, then we have 45 students on a bus. So that's going to be 45 students times Y, which is the number of buses. This will tell me how many students. Questions about that? So now this is my system. Now I have to decide, okay, how do I figure out what X and figure out what Y is? What method do I use? Graphing, substitution, or elimination? Which method do you want to use? Elimination. I would too. Elimination is probably the easier one to use. That means I'm going to either eliminate the x's or eliminate the y's, which that means they would have to be the same. Which one do you think is going to be easier to eliminate? The x's or the y's? Definitely the x's. What can I multiply times this x so that it's the same as 5x here? 5. So I'm going to multiply everything so I can make an equivalent fraction. Sorry about that. I'm going to multiply everything by 5. Okay? Because you can't just change this number without changing all of the numbers and still expect for it to be an equivalent fraction equation, because it won't. All right. So now the top fraction, Lord help me. The top equation is the same. Okay? The bottom equation, when I multiply, is going to give me 5x plus 5y equals 35. Any questions about how I got that? Okay. Now I'm going to use subtraction so that I can eliminate the x's. So I'm going to subtract. So I have 5x minus 5x gives me 0. 45y minus 5y is going to be 40y. And then 195 minus 35 is going to give me 160. Okay. Now what am I going to do to solve for y? Okay, good. Divide both sides by 40. So let me divide that. Okay. So you have 40 divided by 40 gives me 1y. And 160 divided by 40, that gives us 4. Okay. So that means there are 4 buses. Okay. And I'll show you a shortcut as to how to do these problems in the calculator later. I'm not going to show you now because I need you to be able to do this pencil and paper, because this will be a part of your calculator inactive section as well as calculator active. Okay. All right. So how do I figure out what my x is going to be? How do I figure out what x is going to be? Am I going to use the first equation or the second original equation? Which one do you? I would use the second one. Doesn't matter which one you use. You're going to get the same answer no matter which one you're going to use. But I would use the second one because it has smaller numbers. So I'm going to substitute 4 in the place of y. And I'm going to subtract 4 on both sides. So what's my answer for x? 3. So that means there are 3 what? There are 3 cars. If I wanted to check this, guys, this is very important. If I wanted to check this, I could use the other equation. I could say 5 times the number of cars, which is 3 cars, plus 45 times 4 should equal to 195. So let me type this in to see if that checks out to be so. Okay, I'm going to say 5 times 3 plus 45 times 4 equals, and that gives me 195. Okay, so I know that this is the right answer. It checks out. Any questions about that? Did anybody get that right on their own? All right, so now we're going to take notes. This is going to be the second page of our composition notebook, digital interactive notebook notes. This is the first page. And I had 2 pages there, okay, but this is part of the first page. So now my second concept that's in quarter 3 is going to be page 2. So let's put page 2 here. Slide this over some. Okay, and we're going to do systems well, graphing systems of linear inequalities. Graphing systems of linear inequalities. This is a short page of notes. All right, so when you're graphing systems of linear inequalities, it's the same as graphing a system of equations. It's just your shading is going to be different. Okay, the line is going to look similar. Some of the lines are going to be exactly the same. Shading is going to be different. Okay. All right, so let's talk about that. What the different inequalities are. Why do I keep doing it? I do not know. Maybe it's because it's the end of the day. All right. The first we're going to say is the equal sign because we're going to make comparisons of the equal sign to all the inequalities. So here we have an equal sign, which we see with regular equations. And how does that look like when we graph them? It's a solid line and no shading takes place because we have been doing no shading because you don't shade with just the equal sign. The answers are on the solid line. It's on the line. So all the answers are going to be on the equal sign, on the line, sorry, on the line. Okay. The first inequality that we're going to talk about is the less than symbol. This is your less than symbol. Okay. So instead of seeing the equal sign, you might see this sign, which is a less than sign. So you're going to graph it the same way you would graph the equal sign. The only thing that it would be different here is that instead of it being a solid line, it's going to be a dashed line. And no worries, we'll get two examples of what that looks like tomorrow. And you're going to shade below the line. Since it's less than, the shading is under the line. Okay. The second inequality that we're going to talk about is the greater than sign. That goes this way. Okay. Your greater than sign, again, you see there's no equal to under it. Your greater than sign is another dashed line because there's no equal to. And you're going to shade, instead of below, since it's greater than, you're going to shade above. Okay. The third inequality that we're talking about is going to be the less than sign, but then under it, there's an equal to. So this is less than or equal to. Okay. And this one, because there is an equal sign, remember like the equal sign here, it's going to be a solid line. And you're going to shade below. The last inequality looks like this, where you have greater than sign and under it is equal to. So this one is greater than or equal to. Okay. And of course, for this one, there's an equal to sign. How do you think we shade or graph this? What kind of line is it going to be? Do you think it's going to be solid or dash? Solid. Very good. And do you think you're going to shade above or below? Above. Very good. Good job, y'all. Okay. Now, the last thing that you need to know about these, and then we'll learn other stuff as we go, okay? I'm going to put a little asterisk because this is important. Your answers, okay? Answers to, shouldn't say A, to the system of linear, because the lines are still straight, even though they're dashed or solid, it's still going to be a straight line. Linear inequalities are ordered pairs that are on the solid lines or in the overlapping shaded region. And I will explain that in our example, okay? All right. Okay, so this is our notes, our second page of notes, okay? I will pause for the calls. Okay, so we're going to do the guided practice problem number 1, and we'll do the other 3 tomorrow. I'm going to use these notes to do them. Okay. So in the first one, remember when you're graphing an equation, you're going to label your M and your B. So your M is the number that is attached to the X. So my M for the first equation is going to be a -1. To write that as a fraction, you just put a 1 under it. So now you have rise over run. Okay. Your B is the number that has no variable attached to it. So your B here is -2. So now when we graph this, we're going to find -2 on the y-axis, which is right here. And we're going to use rise over run to put points on the line. -1 is our up and down. Since it's -1, go down 1, +1 to the right 1. Down 1, right 1. Down 1, right 1. Points in the opposite direction. Instead of going down 1, go up 1. Instead of going to the right 1, go to the left 1. So this is up 1, left 1. Up 1, left 1. And please make sure that you put points until you run out of space. Okay. Now we look at the inequality. The inequality is a less than equal to. So the line is going to be a solid line. Since it's less than, we shade below. So I'm just going to write below and shade at the end. Okay. Now let's graph the second one. My M is -5. To write it as a fraction, I put it over 1. So the top number is my rise, the bottom number is my run. My y-intercept is the number that has no variable attached to it, which is 2. So we're going to find positive 2 on the y-axis. Positive 2 on the y-axis is up here. So now we are going to use the slope to put other points on the line. This negative 5 means I go down 5. Positive 1 means I go to the right 1. So down 5 is 1, 2, 3, 4, 5, to the right 1. Make this point bigger so it stands out. I don't have enough space to go down more, and I don't have enough space to do it backwards. Okay? So here is a solid line because it's equal to. So I'm going to go ahead and draw my solid line. Okay? And this is greater than, so I shade above. So make sure you focus on what Miss Reyes is getting ready to do so that it does not confuse you. It's not complicated, but if you miss some parts of it, then it could be complicated, you know. All right, so when we look at the first equation, this was the first equation. It says shade below. So I'm just going to lightly shade by just drawing light lines under the line because it's below the line. This is under the line. Okay? The second line says shade above the line. So shading above the line is on top of the line. So since it's leaning like this, on top of the line is this way. So I'm going to lightly shade this way. Just draw little lines. Okay. Now the solution is going to be where the lines overlap, where the shading overlaps. The shading only overlaps down here. So this is going to be my shaded region because this is where it overlaps. And if this graph continued, the shading part would continue to get larger. But since it stops right here, then this is all you see that's shaded. Then I'm going to just erase these other because it's not a part of the solution. The solution is only in the overlapping shaded region. And so this is how all you have to do to show what the solution is. Questions, comments, or concerns? So any point, if they say positive 5 and I'm positive 2 and negative 4, then you say, oh, yes, that's a part of the solution because it's on the line. If they say positive 2 and positive 1, this point is not a part of the solution because it's not in the shaded region and it's not on the solid line. If they say this point up here, this would not be a part of the solution because it's not down here. So only this part of the solid line and the overlapping shaded region are going to be a part of the solution. Any questions about that? Okay, I'm going to stop the video.